Hello, my name is Johnny Yu and I'm in the 10th grade at Mounds View High School in Minnesota. Huntington's disease is a neurodegenerative disease that affects motor output and fine motor control. Huntington's eventually results in the production of MHTT aggregates due to the loss of a specialized class of neurons called medium spiny neurons in the dorsal striatum of the brain. My project specifically focused on the relationship between these MHTT protein aggregates and the loss of the cortical and striatal neurons. In the past, a specific relationship between these two factors has not been determined due to various environmental setbacks. This has caused many treatments that have been administered in both humans and mice to be unsuccessful in mitigating certain HD symptoms. Using a mouse model called ZQ175, which is a relatively new mouse model, my objective was to analyze and determine the abundance of the cortical neurons at 3, 6, 12, and 22 months, while determining the MHTT protein aggregate abundance at the same time points. I hypothesized that the presence of MHTT aggregation will have a direct negative impact on the abundance of neurons at every time point in HD progression due to the known toxicity of the aggregates in the brain. After experimentation, I found that there is a progressive exacerbation of MHTT aggregation as shown with dramatic increases in aggregate abundance from 3 months to 22 months. In addition, I did not observe any presence of MHTT aggregation in wild-type mice, which do not have any HD symptoms. Also, I discovered that the progressive depletion in the number of neurons was significantly higher in the HD mouse model compared to the wild-type mouse model. Also, I found that the rate of neuronal loss is significantly higher in the later stages of disease in both wild-type and HD mouse models. This is significantly different from the relative stability of neurons during 3 and 6 months. Overall, I discovered a negative correlation between neuronal abundance and the presence of MHTT protein aggregation in the dorsal striatum of the HD mice. This correlation between the survival of neurons and aggregation shows the ability of these aggregates to overpopulate and increase the chances of being in contact with more fragile and vulnerable neurons. At around 6 months of HD progression, the presence of mutant Huntington aggregation is more likely to allow for increased neuronal loss. Using this data, we can conclude that the threshold values at which neurons in Huntington's disease cannot cope with certain stress factors, one of them being HD MHTT aggregation, is very prominent in the later stages of HD progression compared to earlier stages. After 6 months, neurons become more vulnerable and overwhelmed with the increased presence of MHTT aggregation.